So our model is going to look at the interplay between executive function and synchrony, and how that synchrony between two people can also be used for emotion regulation or co-regulation. So how they can kind of balance out each other's emotions by synchronizing their behavior, expression of emotion. Background knowledge?
Yeah, so synchronization can occur within oneself across different modalities. For example, when your facial expression, body movements or gestures, and spoken speech align in some way. So for some examples, if you're angry, you might scrunch your face up, make some sort of fist motion, and so this alignment between body and facial expression and emotion, and such synchronization between modalities within an interlocutor is associated with conscious emotion, which thereby affects behavior, which we'll get into more soon. And such interpersonal alignment has also been found to support interpersonal communication and interpersonal alignment. So on the other hand, interpersonal synchrony is the time matching behavior across different modalities between two or more agents. So in this example, the two agents are both creating the same facial expression with the same body movement. There also can be interpersonal alignment with the language use, so the type of words people use, and also the articulation can be synchronized. And such forms of interpersonal synchrony are accompanied by changes in interpersonal affiliation. So often when people are behaviorally synchronized, they become conceptually and emotionally synchronized as a result. And these changes suggest some subconscious facility to detect synchrony between two individuals. So individual variation in executive functioning, which includes domains like inhibitory control and attention, is associated with altered synchrony patterns, specifically in intentional synchrony, but not spontaneous.
Yeah, maybe as an example, spontaneous would be like if you're walking next to each other and you kind of match your faces, but you don't really think about that. And intentional is more like, for example, mimicking their facial expression and gestures. It can also be sometimes spontaneous, I suppose, but intentional is more focused on something that matches both in form and time, and spontaneous is more about the temporal aspect.
Okay, so an example of altered synchrony pattern associated with executive functioning alterations is people with executive functioning or with attentional differences often will direct their eye gaze toward different objects and not be in alignment in terms of where they're looking. Another aspect is individuals often adapt their behavior according to their conversational partners' executive functioning skills. So example, in one study, individuals with higher spatial ability tended to become more aligned with individuals with lower spatial ability, which was compensated for the negative effects of lower spatial ability on the task that was being measured.
Okay. We have developed a model. Well, first we based it a bit on Sophie's model, which Jan covered in the lectures as well. So it's a multi-adaptive agent model for intrapersonal and interpersonal synchrony. So we're looking both like at alignment between modalities in one person and between two people. And some of the assumptions are that we must have some kind of mechanism for detecting synchrony, and that mechanism allows us to adjust our synchrony and increase interpersonal affiliation. So becoming kind of more friendly or familiar with people. And Sophie also assumed that this was more about behavioral aspect of it. So like matching your expressions and things like that, rather than like this cognitive effort to synchronize. Yeah, and there's also the connection with conscious emotion with Synchrony, which in turn will affect behavior. Yes, and we have modified this, but this is what was there initially. And you can see kind of going from, we have two agents first, there's A and B, and there's the sensing, representation, preparation, and this is per modality, that's why there's so many. You have like the talking and expression and body movement. And then these, once you have like kind of prepared the emotion, will connect to the conscious emotion and the expression of it as well. And then there's detectors for both interpersonal synchrony and interpersonal. So that allows the person to don't know what the synchrony state is. And the agents are just very similar in the setup. They just kind of mirror each other. You'll see that in our matrix doing a bit. It was a very complicated model that we made a bit more simple in ours. We removed the second verification level for one. And some of the main things that we wanted to do was to add some states that would allow us to differentiate between someone with more or less executive functioning ability. Feel free to interrupt me if you want. The three main things here are attention state. So for example, someone with ADHD or someone who just has low executive functioning, could be also other disorders like autism spectrum. Their attention, we hypothesize, would affect their ability to detect synchrony, because you need to keep track of your partner and their face and body, and you need to like also move your gaze and attention and everything, and it can be quite demanding. So if that is a problem for you, it might also impact synchrony. And similarly with inhibition, if you are better able to inhibit your own emotions, you can kind of take on the other's perspective better, and we think that could also impact synchrony. And then we implemented ownership states just to kind of differentiate between our own emotions internally and the other's emotions that we are simulating, because they kind of use the same loop. So we want to know that we are inhibiting the other's emotions more than our own, because we think we feel art more. It's beautiful, messy model that we made, and I listed the differences. Do you want?
Yeah, so you can see here that the attention state comes between sensing and representing. So, like Ethel said, the amount of tension or lack of attention that someone is exerting in this process will modulate what they're sensing and how they're representing it, while inhibition comes a bit later, is more involved in controlling the preparation of an affect or movement, and also the expression. So inhibiting or not inhibiting your expression or movement. And then the ownership states, which are other set of controllable states that we added to this model, allow our agents to differentiate their unconscious emotion from the conscious emotion of their partner. And we also added a first level of verification that is not shown here, but that modulates the connection between each A's expression and D's expression states for affect and movement.
Yeah, maybe some important differences. We decided to focus only on two visual modalities, because we thought that visual and audio modalities like speech and language, they would probably work quite differently. So to keep it a bit simple there. And the additional states we mentioned, attention, inhibition, and ownership. And just to explain how the synchrony section works. It's similar for both within person and between people. It's basically just looking, for example, if it's for yourself, if your like facial expression is aligned with your body expression, by seeing if they both have high or low values at the same time. And for interpersonal synchrony, it does it by modality. So like, see if you're smiling at the same time, for example, or frowning at the same time.
And I will note that we ended up differentiating or making two personal synchrony states for each modality,
Yeah,
which is reflected here. Will be.
not that you can probably make a
Yeah.
match anyway, but we'll make it digital and pretty soon. Didn't get to that yet. Okay, so in terms of the matrices, this is how it's represented, similar to what I kind of explained in Sophie's prettier digital graphs. You have the face, body, and context states. So you're looking at both your own face and body and also your partner's face and body, and the directionality of that is shown with the B and A. So in this case, it means you're sensing B's from B to A. So A is sensing B's face state, for example. And then you have the attention and inhibition, the additional states we added, and the ownership. One thing to note, inhibition has negative connections to pretty much anything it is connected to where you see the 16. So it's a way to suppress emotion preparation, expression, as well as conscious emotion. And it is related to ownership because we want to inhibit the other person's more than our own, or like what we simulate that they should be feeling. And the other agent is just mirrored from agent A, but we reversed the directionality. So now B is sensing ACE states. So we end up with 42 states here, and then we add first verification level to add some adaptive connections between the connection weights for each agent. I'm sorry, the expression connection weights for each agent and each modality. This means that we have adaptive connections in the connection weights matrix there for the expression ones, which are like where you are smiling or moving your body, for example.
Yeah.
And the thresholds.
And just to clarify, agent A is modeled as having lower attention and inhibition, while agent B is modeled as having higher attention.
Yeah, except for when we make the pairings where both of them have the same. Yeah, we are going to look at it in different pairings once we get to the simulation, because we wanted to see, how these things interact in pairs. These again, I guess did I mention it? Yeah, this is how we differentiate between the different executive functioning profiles. So the one with high executive functioning, or you could say typically functioning, has a faster attention regulation and faster inhibition of emotion, and lower thresholds for activating both of these. And it's the opposite for the lower functioning, or slower attention regulation and inhibition, and higher thresholds for activating these states. So we have done, the simulations in 3 pairings. We have low, low, high, high, and low, high. And I did it over different time steps. So one is supposed to model one 30-minute interaction. So it's looking at, in a shorter window. Yeah. You'll see it a bit better now. It's interesting so this is the low and low functioning. They kind of go up fast in their synchrony, and then I guess there's maybe some fatigue or something that dips again and goes up again, whereas this, where you have 2 different types, the synchrony is reached, I would say, the slowest, but it does get there eventually. And some of these also remain quite low. This is the intersynchrony, the green one for one of the agents, and for the other ones, it's the yellow one. And here in these pairings, you can see the yellow and green lines are higher, and here they get higher as well, but not as much as in the low functioning, double low functioning pairing. Sorry, it's a bit confusing, but yes, different patterns.
Just to foreshadow our discussion and interpretation of our
Oh, you can you go back to the, you want to go back to here?
Yeah, is that having one highly executive functioning agent seems to lead to some stabilization over time.
Yeah, I think you might see it better in the next one. Yeah, I was going good. But now it's like 120 times that's instead. So imagine we're repeating the 30-minute interaction 4 times, and there's some kind of like break in the middle where the values kind of drop, or they stabilize or forget things. And here you can really see the patterns. So there's really like regular oscillating patterns in the double high functioning pairing. And they're quite similar as long as you still have one high functioning executive functioning person. It's just a bit like slower and washed out, but you still really see the same oscillating pattern. And when you have both individuals with lower executive functioning, it changes quite a bit. It's like more chaotic, and the pattern is slower to emerge, and it's different. And it's a slower pattern as well because it's more over 2 interactions, whereas this is over one-ish.
Yeah, so simply put, just having one high executive function agent mitigates the effects on synchrony of the low executive function.
Yeah, and these, by the way, of patterns and the now patterns, this is like the intrasynchrony, and this is the intersynchrony mostly. So within yourself and within the pairing. And then we also plotted it separately so you can see the line because there's so many. Otherwise, for emotion, inhibition, and attention in the same pairings and in the same like first over just the 30 time steps and then over 120. Here some like, interesting things happen with the low executive functioning. There's like these very diverging lines that one kind of stays minimum and the other maximum. Yeah, maybe there's something strange going on there, but more of a normal pattern again with the both pairings that have at least one high executive functioning person.
Yeah, more the extremes for the lower executive function.
Yeah. But curiously, the attentional states, are quite high. So we could interpret it as them being like paying attention to too many things or hyper focused or something like that. But it could also be that there's something strange going on there.
Yeah, to be interpreted.
Yeah. So over the long term, again, you get the oscillating patterns better. As long as there's one high executive functioning person, you see a similar pattern. And if not, it is more strange diverging thing where we have one of the agents with low executive functioning has, sorry, this should be LEF and LEF. One has very high conscious emotion and one has very low. So it's like one person is being very intense and the other is just shutting down completely.
Or modulating happening with the other pairs. To reiterate, very similar synchrony patterns between high executive functioning pairs and mixed pairs, where there's regular periodic oscillation patterns in synchrony across time. But when you introduce, when there's two low executive functioning agents, the patterns are more variable and slower oscillating pattern over time. So less normalization.
Okay. And yeah, a similar thing happens with the emotion as well. Yeah, the strange point about attention being high for both partners and the difference between one having high emotion and the other low.
Yeah, so I was mentioning during the background section, various research has found that high ability individuals can identify and compensate for partners with lower ability in various executive functioning domains, including spatial ability, which pairs well with our simulation results that indicate that just having one agent with high executive functioning allows for more normal or regular oscillations and synchrony and conscious motion. And similarly, the extreme highs and lows in conscious emotion found in low executive functioning pairs supports findings that individuals with executive functioning alterations struggle with emotion regulation within themselves, but also co-regulation with others.
I think that's everything. Future directions. Sorry.
Yeah, so as I mentioned just now, the low executive functioning pairs exhibited high attention states, which kind of went against our predictions, but yeah, have to interpret that finding. And also there's a lot of research on how increased interpersonal synchrony lends itself to higher interpersonal synchrony. And at this point in time, we don't have a clear connection. Or
Not a
any connection
direct
at all. Yeah, no direct connection between interpersonal and interpersonal synchrony, so that's something to incorporate in the model.
And yeah, we also want to add more modalities like speech and gaze, because for attention, the first thing you have to be doing is looking in the right place, for example, and there's an additional step of attention. And we also want to differentiate more between the synchrony that happens automatically and the one that is more intentional. Because, for example, only the intentional one in literature is impaired in ADHD or people with executive functioning, because that's probably more related to attention than the automatic one. And we also want to differentiate between negative and positive effects, because that also matters in emotion co-regulation. And yes, ideally, we eventually would want to compare with experimental data if there's
Yeah, and also the compare our simulation results with those of the initial model.
yeah, we didn't get to that yet.
Yeah.
Okay, thank you for listening.